Welcome to Module 1 and 3 Basic Concepts. The three basic concepts are languages, grammars, and automaton. In this video, we're going to talk about languages and get to some properties of languages. And first, we're going to start with some definitions. So the first definition is an alphabet. So what is an alphabet? An alphabet is a finite, non-empty set of symbols. So we'll use the symbol sigma for an alphabet, and you can see the set here of the alphabet is the letters A and B, and they're in this set here with set notation. So in this situation, this alphabet is made up of the symbols A and B. You don't have to use letters for the alphabet. You can use numbers or any kind of symbols. It just has to be finite and non-empty, and we will use the symbol sigma to indicate for alphabets. Strings. So you can construct strings from the alphabet. So this is an example of a string, AAA, BBA. You can also name the string. So this part right here is an example of a string named W, and that string is ABAAA. That string is constructed from the alphabet A and B. You can concatenate two strings together. So this first string has the name W and it's ABAB. The second string has the name V, it's AAA. So you can concatenate the string W with the string V, and that is putting two strings together. So just as a review, you have your sigma, which indicates the alphabet. The alphabet is a set of symbols, must be non-empty, must be finite. In this case, this alphabet is made of the letters A and B. You can construct strings out of this alphabet, and then these strings are going to be a part of languages, and that's what we're going to define different types of languages eventually. One thing you can do is you can concatenate two strings together. You can name your strings and then concatenate your two strings together. So the name of the string would be W and the other string is V, and when you concatenate them together, you concatenate them as WV, and that is just those two strings put together. You can also have a string and take the reverse of the string. So we have string W, which is ABAB, and the reverse of string W would be BABA. The length of the string, that's how many symbols are in the string. The empty string, okay? The empty string also exists in a language, and so we have to make sure that we understand what the empty string is. The empty string is not the same thing as the empty set. The empty string is the empty string. The size of the empty string is 0, but some languages include the empty string and some do not, and we will get to an example of that shortly. All right, W to the N, that also can stand for the length of string. W has the length N. So that's another way to do that. You can have the length of W, and then you have to say what the length is, or you can say W to the N, which would mean that W has the length N. So if it has three symbols in it, then the size would be 3, and N would be 3. W to the 0, so if you have string W and it's to the 0, obviously then the length is 0, then that is the empty string. So the size of the empty string is 0. Okay, so again, just to review, we have sigma for the alphabet. So if sigma is your alphabet, say A and B or 1 and 0 or whatever symbols you decide to include in your alphabet, then sigma star, that is a language, okay? So sigma star is an infinite language. That language is every possible string that can be made out of a particular alphabet. So if your alphabet is AB, sigma star is going to be A, B, AA, AB, 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 every single possible combination that you can make out of that alphabet, including the empty string. Sigma plus is going to be sigma star without the empty string. So both sigma star and sigma plus are infinite languages. You take an alphabet, every possible combination you can make out of that alphabet, is an infinite language. Okay, a sentence. A sentence is a string in a language. So here is an example, and this is what I just said before. If your alphabet is AB, then sigma star is going to include the empty string A, B, A, B, B, A, and it's an infinite language. Every single possible combination you can make out of your alphabet AB. Okay? You can also have smaller languages. So here is an example of a set, A, and A, B. This could be following some rule. This is a language on our alphabet AB. So not every language is infinite. This is a finite language that is based on the alphabet AB, and it is the set of the following strings, A, and AAB. Here's another way to define a language. So here is a language that does include the empty string. This is a language that is A to the N, B to the N, where N is greater than or equal to 0. So this is a definition of a language. This language is, it includes the empty string, and the definition of this language is that it's any number of A's followed by the same number of B's. So this included in this language could be the empty string, could be AB, AABB, AAABBB, and so on. All right, so now here's some more things about languages. Let's talk about the complement of a language. So the complement of the language, the way that you write complement is, so L, say we're going to define a language as L, then we would define the language complement as L with a line over it. That would be the complement. Another way to write the complement is to put a little C. And this is how to do the reverse of a language. So this is, remember that a W is a string in the language, where L is the complete language. Okay, so a complement of the language, if you take sigma star and you subtract every string that is in that language, that is going to give you the complement. So remember that sigma star is every possible string that can be made of a language. Then you define a language, you subtract that language that you just defined from sigma star, and that gives you the complement. Okay, the next thing we're going to talk about is the reverse of a language. So the reverse of a language is going to equal the strings in the language that are the reverse, such that every string that is in the language. So let's look at this notation. You take all the strings that are part of that language, and each string that is in that language, you reverse it. That is going to be a member of the reverse of the language. So we need to get used to this notation. All right. So languages are sets, and they you can define, because they are sets, you can define union, intersection, and difference, and concatenation. So let's first talk about concatenation. So say you have two languages. So again, remember that a language is taken from an alphabet, and you can make a definition of that language. So we have different languages. We showed a finite small language. We also showed infinite languages, but you define whatever that language is, and then you can concatenate the two languages together. So if you have language 1, which could be a finite language, an infinite language, it doesn't really matter. It's just a whole set of strings in language 1, and then you have language 2. So that all of the strings that are in language 2, concatenating them together. So this is the notation for that. You take X and Y, such that X is a member of L1 and Y is a member of L2. So let's take a look at this. This is the set of the concatenation of two languages. So you take every X, that's a member of L1, and a Y, that's a member of L2, and you concatenate them together, and that is going to give you the concatenation of two languages. All right, so let's talk about a couple more things. L to the N. L to the N is defined as the language L concatenated with itself N times. So just to set up for that, we have L to the 0. L to the 0 is going to be the empty string. Then L to the 1, of course, is going to be L. L to the 2 is going to be L, L. L to the 3 is going to be L, L, L. So in the previous slide, we showed what concatenation was. So every string concatenated with itself in the language N times would be L to the N. Okay, so that's going to get us up to what star closure is. So star closure of a language is defined as the union of L to the 0, which it includes the empty string, union with L to the 1, union with L to the 2, union with L to the 3, and so on, all the way up. It's an infinite language. That's what star closure of a language is, and positive closure of a language is defined as the union of L1 with L2, with L3, etc. So if you can notice the difference between positive closure and star closure is that positive closure does not include the empty string. All right, in the next video, we're just going to go over an overview of the terms and understand a little bit about grammars.